Welcome, ladies and gentlemen. Today we are going to be investigating trapezoids, isosceles trapezoids, and kites. So please make sure that you have all of those shapes that I have provided for you in class, okay? You also need your notes, a pen and or pencil, and a calculator. First thing we're going to talk about, ladies and gentlemen, is the kite. So make sure you have this picture taped in your notes. Now, the kite, we're going to talk about the angles, sides, and the diagonals. Now, this one is very unique. So when we're talking about the kite, our angles, one pair of opposite angles are congruent. Now, when we have these ones, those are the ones that are going to be the same. If you notice, B and D, D is really tiny, B is really big. So that leaves us with A and C. So for this, angle A is congruent to angle C. Now, also, now we're talking about our sides, the two disjoint pair of consecutive sides are congruent. So, there's two pairs, the ones that are disjoint that are connected next to each other. So in this scenario, AB is going to be congruent to BC, and AD is going to be congruent to CD. So if you want AB is congruent to CB, and AD is congruent to CD. Alright, now let's talk about some diagonals, shall we? The diagonals are perpendicular. That means when they meet right here at this point, all of these angles, ladies and gentlemen, are going to be right angles. So make sure you put these in. Make sure you're getting all this written down and all of these put into your picture, alright? Also, one diagonal is a perpendicular bisector of the other. So if we look at these ones, if we were trying to figure out which ones look like they are the same measurement, so we're going to go right here. A to E and C to E. So AE is congruent to CE. We also know that one diagonal bisects the opposite angles. Now, this case, we're going to be talking about angle B and angle D. Okay, those angles will be bisected. So if I said this is 1 and this is 2, here, the measure of angle 1 is going to be congruent to the measure of angle 2. And up here, this angle is congruent to this angle. So if I said 3 and 4, the measure of angle 3 is going to be congruent to the measure of angle 4. Alright, that's all we have for kites, so make sure you have all that written down. We're going to move on to the wonderful trapezoid. So if we look at the trapezoid, this one we're kind of thinking different than we have lately because all of the sides are different. This one has nothing unique. They're going to have all different sides. Right? Now, their bases are parallel. So the bases are going to be parallel. In this case, it's going to be BC is parallel to AD. So BC is parallel to AD. Now we're going to move on to their angles. Their angles are also all different. So when we're just talking about a trapezoid, the sides are all different and the angles are all different. Now, each lower base angle is supplementary to the upper base on the same side. So this is really important. We're talking about lower and upper, and they're going to be supplementary. So in this case, if I was talking about measure of angle B, that's an upper base angle, so the one on the same side that's lower than that is going to be measure of angle A. So if I add those two together, I'm going to get 180. Now the other set that we could do that is the measure of angle C plus the measure of angle D is going to equal 180. All right? Now, as far as the diagonals go, there is nothing unique about our trapezoids. and there are diagonals. All right, so now that means we get to move on right here to isosceles trapezoid. Here we go. As far as these are concerned, the legs are congruent. So not the bases, the other sides are legs. So AB is congruent to CD. We also know that the base angles are parallel. So now we were talking about the legs, now we're talking about the base. So we're going to talk about this side and this side being parallel. So BC is parallel to AD. Now if we go on to the next one here, we're talking about our angles. Our upper angles are congruent. So the ones that are upper, so here we're talking about B and C. So angle B is congruent to angle C. Then we also know that our lower base angles are congruent. So if we're looking at the lower ones, we're talking about A and D. So angle A is equal to angle D. Some more fun facts about our angles. Any pair of upper base angle is supplementary to any lower base angle. So I can pick one upper base and one lower base, and they're going to add up to equal 180. So I'm going to give you one example for that. If I picked B right here, I could pick A or D. So if I said the measure of angle B plus the measure of angle A is going to equal 180. Now I could also pick measure of angle B plus the measure of angle D, and that would also equal 180 degrees. Also, if I wanted to think about it the other way, I could think about angle C. If I wanted to say that measure of angle C plus the measure of angle A could equal 180, or I could say the measure of angle C plus the measure of angle D could add up and equal 180. All right, moving on. Oh, and the diagonals, you guys, are congruent. So that's really important. We need to write down that AC is congruent to BD. All right. Now, ladies and gentlemen, we're done with our shapes, but we need to talk about our trapezoid a little bit further. We need to talk about the mid-segment. So this whole slide I need you to have down for me, all right? The mid-segment of a trapezoid is a segment that connects the midpoints of the legs. Okay, so we're going to cut our legs in half. So it's very important that they have parallel bases, which we know about trapezoids. And then the length is equal to half the sum of the bases. So please, please, please make sure you get number 2 written down right here. The length is equal to half the sum of the bases. So when we talk about that, half means we're going to what? Divide by 2. Sum we're talking about adding. So that's really important that we know that. Moving on. All right, here comes example number 1. I have 2 examples for you and then we're done. So make sure you get both of these into your notes, please. In the diagram, HK is the mid-segment of the trapezoid DEFG. Find HK. So I'm going to put in an X right here. Now, with that mentioned in the last one that we just read, the sum of these 2 bases. So I'm going to take 6 plus 18, and then I have to take it half of this. So I'm going to add them together and divide by 2. So if I add those together, I get 24 divided by 2, which is 12 centimeters. All right, moving on to the last example. So this last thing you need to get into your notes, please. If segment EF equals x plus 5, so I'm going to plug that in here, e to f, so I'm going to put x plus 5, and DC plus AB equals 4x plus 6, find EF. So if I've already added them together, those two added together already equal this, so I'm going to put 4x plus 6. And remember, we have to divide it by 2 equals EF, which is x plus 5. So if I want to go about solving this problem, I'm going to first get rid of this 2, so I'm going to multiply both sides by 2. And I'm going to, there's going to cancel, and I get 4x plus 6 equals this. I need to distribute in, so it's going to be 2x plus 10. Now I'm going to solve for x, so I'll subtract 2x on both sides. 2x plus 6 equals 10. Subtract 6. 2x equals 4. Divide both sides by 2. And x is going to equal 2. Now, it didn't ask me to solve for x, it asked me to solve for EF. And I know that EF equals x plus 5, so I'm just going to plug in 2 for x. So we're going to get 2 plus 5, which equals 7. And there is our answer, ladies and gentlemen. All right, that's all I have for you today. Enjoy the rest of your wonderful day, and I will be seeing you soon. Bye.